This is Gerald Johan van Was in the educational channel of demonstrations regarding the sound-informed theory, and the theory is not given so much attention, but in these couple of videos, this is the second of these videos, I will also show you how the language itself, the letter combinations themselves, are guided by a principle that is that could also become another layer of that, which is a little bit more scientific, which you can also use more scientific, and it builds up in a similar way as for instance the algebra in mathematics follows up logical steps. It isn't explained very often how algebra even follows a logic from logic itself. It means if you need more conditions, the conditions needs also different calculations. The same thing happens in language, the same thing steers in language, but it is another principle, and I will show you the differences and how they can interact, how the algebra itself can interact with the letters, the letter combinations, the words. The language itself is not following the same rules in such a way that it will allow you to intervene. It will allow you to go quickly in another direction, or change a perspective, or adapt. That's what it is. You have to adapt more quickly. The numbers are neutral. They always follow the same rules, and they grow and grow and grow in complexity. The same thing is visible in these letter combinations as well, but it slightly follows other rules because it has also a possibility to intervene more quickly. And in this video I will show you the principles further of what I call a subjective mathematics, which you have to use in language and how it works in language. And this is the second of my videos. I already explained the first logical steps comparable to the algebra, and I also this was the basics of the scheme where we ended. What can you see on the scheme? I will go through it very quickly. Underneath you see the table, and on the table are put some objects on a horizontal line. This was the first layer of putting things together with a plus numerical order of all things were equal and they are added up, so are equally arranged or equally added. They're not so strongly bonded. They're just random objects that you put together and you count them or you put them together. That's the A. It's around an idea that all things are equal and they are treated equally. It's a centralized vision, which is also defined by how you define this neutral togetherness. And you have an idea about it. It has a certain complexity, and the number of this complexity is like the number 1. It has a definition from the rhythm. It has the amount of a number, but it also has an amount of what hangs together as an entity, as a separate entity. The separate entity has a number, the number 1. But if your definition changes, you can have a lot more objects together within this definition. If this is a very simple and simplified vision, very quickly things will not add up, and what you thought at the beginning that could be arranged as similar as objects that were all neutral or all could be handled in the same way, that it can't continue to work like this, and you have to adapt. And this adaptation process is the starting point of language. But in the beginning you have one. Everything is one. And it is actually your own viewpoint. It's one person who decides this and tries to continue this as their central point of vision, the central perspective. Once you find out that there are some features different in some of the objects, you have to add some extras there, and you say, okay, I deal with them, but I will still treat them the same way. Once you find differences, it's the letter T. It's a little bit more than one then, but if you can still treat them as one, you can say, okay, I will have them with the extra. I notice the extra one, but I still consider it as A, so I'll have T plus A, or Ta. I will use this letter combination where I can say, okay, I will continue my logic, but I have some extra, or I notice something extra, but I don't mind, I continue. But if this extra, which is another category instead of the plus, it's actually that you say, okay, something is actually not fitting up, it's a little bit different, but it's still less than one. It is there, you see something is slightly different. It's, let's say it's 1.1 or 1.2 or 1.3 if you see, if you see it as numbers. Once it's really different, like let's say it's 1.1 in a number, it doesn't mean a number, you see that it's already a little bit more than the other, so you have you are in a vertical position also, and the other way you say, okay, I add it to the one, okay, it's a little bit more, I realize that. This is the add. I will add on top an extra feature, and it will still be useful in my logic, and I deal with it in that way. As soon as you're not longer sure that it all fits very well, so especially when it's more than 0.5 or 50% difference, you're having doubts if it still works in your logic that you already use, and then you are at the next letter, the letter K, which is your first reminder that maybe your system of thinking, your definition is not good enough to keep using all of that, because it's already so much difference from your center. It has a tendency that it will break your own logic apart, or it will go to somewhere else. It needs an adaptation. That's the next more profound adaptation that it needs is the K, and it's a very important change in perspective in your logic as well. As soon as you see there are so many differences between two positions that you have to consider it as another position, it can work, or in your own logic, in your starting point of logic, can only work if it is an other equal. But in this case, it's an equal of perspective. It's an equal of all of the elements. So your elements have the number 1, so it can't be bigger than the number 1 as well. The number 2 is bigger, but it is bigger because you also include your own perspective, your perspective, and the other perspective is both of them are 1. So 1 and 1, you have the 2 times 1, or you have 2. What you don't realize all the time is that you are dependent of your thought process. In this case, when you reach the number 2, you can only work with it if you access it as, and you compare it as a comparable of other 1. So you're still using number 1. But let's now compare the differences that you notice on its way between 1 and 2 a little bit better, and see how logic of language is still different from the logic in mathematics. It's slightly different. It's based upon the same things, but here we also have this reason of doubt and the adaptation process, which we can also use to change the complete system as well. So we have the numbers on one hand and the letters on the other hand. And I will show you the differences between it. Just imagine that you have already 3 objects, and one of these objects is clearly different. You have here a green dot, another green dot, and another red dot. You see the difference. How can we use it similarly? There are different ways to use it similarly, but I will use objects to make that clear. That's maybe more easy. Let's take the objects of the apple. We started from the apple. We found another apple. And at some point we found a pear, and we also have that one. Now, we already noticed that the pear is different. And yeah, in a way we still notice them, we consider them still as somewhat the same thing, but it's not exactly the same thing. So how can we define them? There's a difference, but how shall we adapt this difference? Once we notice this difference, we have to find a definition for it. There's no other way. So let's say, okay, apple and pear, they are fruits. So we have here an apple, 2 apples and a pear, and they're fruits. So we say our definition, which is here we need the calculation of mathematics of division by calculated by 1 here. So 1 is the structure where you don't need to change anything, and then you know how much you have, how many connections you have, and so on. It's a kind of calculation. I could go deeper into it, but I will not do that. But I will give you some examples how you can use it differently, the division. So the division of definition, in this case, underneath, I showed it as 1, makes a difference, because here I have my definition. Just imagine I use a new definition. I say, okay, now I can use the apples and the pears into one definition. I have fruit. So everything is the same thing for me, and I can still use the same logic. In apple and pear, I can use the same logic. So because I have the definition, it confirms my definition of fruit. So how much do I have there? If I compare it, it's 1, because I consider it as the same one and the same thing. It's all fruit. So I have here 1 from 1. That's not what I wanted to say. I wanted to say something else. No. I wanted to have a neutral way to make a distinction. So I'll try it another way. In a way, I could say I want to use neutral aspect. So I choose 1, and this 1 I made dependent of fruit. Because I made it dependent on fruit as a definition, all of it fits in the definition, and when I would calculate how much of this definition I have only 1. I have the apples and the pear, but it's actually only 1. So that's not what I want. I want more distinction. From here there is not the distinction that I want. To make a distinction, so I have to go further. I have to use the number as a calculation. So I'll try again. I have 1 divided by fruit divided by the number. The number is the neutral thing. So I'll try again. So what's the number then in this definition? The number is 2, because I have from my definition, which I use fruit to calculate, I have 2 sorts of fruits. So I have 3 objects, I have 2 sorts of fruits. So I still don't have the definition that I want. I want something more neutral. So in order to find something neutral, I have to find the number, of course, before I can say, okay, I have here 3 objects of fruit as a number. So that's some of the definitions. And that's interesting because you can use, this way it is using language, it's using mathematics as well, it's using logic as well to make some of the distinctions to get you to the distinction between objects. It's so purely with the neutral aspect that you think is neutral is not always useful. So if you want to distinct definitions, you have to know which kind of definition in the starting point that you use. And there we come to the language logic. The language logic that I use also in Sound in Form is based upon a structure, and the structure is numbers, but it goes beyond numbers, and each number is also divided into 3 phases. You have the new phase, which is the 1, that is starting to form itself. So it's my first idea of 1, it's coming to 1, and that's my apple. That's the Adam apple, which is found, and the Adam apple is going to be used as the first idea of what I'm going to find in the world. So I find another apple, I have an addition, then I'm sure, yes, I have my number 1. But at a certain point, you also found a pair. And there's a difference. So I can't continue my idea of what was 1, and I have to adapt. This is the moment of doubt. And that's important because this moment of doubt will get you to the next level of division. This division can't be used from continuing the logic that you have. So you have to adapt your logic. You have to adapt the center starting points that you started from. And that's what language does. Language directs you in a different direction. So I have I had already some options. So with the fruit, I know that I had 3 objects and 2 sorts of fruit and another definition of the general thing, which was fruit. So I had it, or now I actually in this very short time I made a distinction between 3 different kinds of definitions. And that's one of the starting points that is very important, the directions and changes of directions within every region of where you meet next levels of letters is doing that kind of thing. It's refocusing, it's adding definitions, and and the neutral part of the numbers alone will not help you here. There's not more needed than that, and I hope this video helps you to understand that language itself has its own logic, and that I developed it from there, discovered it from there, and this is the more logical, comparable to mathematics, if you wish, to something more scientific. You can build up the logic further from there. I call it subjective mathematics because that's what it is. You have to realize, what do I need, where is the moment of doubt, and what is it about, and what do I need, and how can I still keep the balance that I have a 1, and what is my 1, what is my neutral part. If I know the neutral part, I can calculate, and I can calculate correctly. That's how the 2 apples in the pear at some point are 1, at another point are 2, and another point are 3. All of them are correct depending on your perspective, and this perspective is just the perspective of need. And within these 3 differences, there is a neutrality and there's a moment of change, and there's a moment of need. They all participate in directing your thoughts, and these directions of thoughts are much more like language than they are like mathematics. Thanks again. Bye bye. Check the website out for more if you like. There are mostly lists of words, and some of the theory is separated as well.